Dear students, welcome to today's chemistry session. As today, we already discussed the chemical properties of alkenes. Chemical properties of alkene. So, we are taking the chemical properties of alkene. What is the first reaction? That is addition reaction of alkene. So, addition of hydrogen with lithium or platinum or palladium. We make it the alkene. And the second reaction, that is addition of halogen, that is halogenation. And on halogenation, we are getting 1,2 dichloroethane and ethylene is involved. And the next we are taking Markovnikov rule. Do you remember? It is Markovnikov rule. So what is it? Markovnikov rule. Markovnikov rules. What is it, Markovnikov rule? Please. Here, in an unsymmetrical alkene, we are taking propylene. That is CH3 bond CH double bond CH2. This is an unsymmetrical alkene. And unsymmetrical alkene, when it is treated with, that is HBr. We are taking HBr, hydrogen bond. Then here the negative part of an addentum is going to attack a carbon which contains least number of hydrogen. This is Markovnikov rule. So here the Markovnikov rule is the negative part, and here we are taking that. Which one is the negative part? Listen. Here in the HBr, Br minus. This is the negative part. The negative part is going to attack a carbon, any of 3 carbon, and which carbon we want to determine by Markovnikov rule. So the negative part of an addentum is going to attack a carbon which contains least number of hydrogen. Listen, here if you are taking the first carbon, it has 2 hydrogen, and the second carbon, it has 1 hydrogen, and the third carbon, it has 3 hydrogen. Okay, so among the 1, 2, and 3, which one has least number of hydrogen? Which one has least number of hydrogen? Then it is the second carbon has least number of hydrogen. It contains only 1 hydrogen. Okay. Now, what will happen? The negative part. Among that HBr, which one is the negative part? Then H plus and that Br minus. So the negative part is going to attack a carbon which contains least number of hydrogen. Then it is the major product in the case of Markovnikov rule. So we are getting a major product. What is the major product? It is CH3, CH3 bond CH, and here the Br is jointed and bond here it is CH3 because the hydrogen is going to attack here. So that this is the Markovnikov rule. So we may get it is 1 bromopropane. 1 bromopropane. So 1 bromopropane is the product. 1 bromopropane. Okay. Now, if we are taking that 1 bromopropane is a product. Now we are taking that is anti-Markovnikov rule. Okay, listen. Here, what is it? Anti-Markovnikov rule. So we are taking that is anti-Markovnikov rule. Anti-Markovnikov rule. Okay, listen. And here the negative part. There is opposite one. Here we are taking the same compound, that is propene. What is that? Here it is a CH3 bond CH double bond CH2, and it is reacted with the same, that is HBr. Okay, which one is a negative part? That is Br is a negative part, and hydrogen is a positive part. Now, in presence of peroxide, we are getting that it is peroxide. So, in presence of peroxide, generally we are using that is organic peroxide. Organic peroxide. In presence of organic peroxide, what will happen? Here, the reverse one. What is that? Here, the Br is going to attack. That is, we are taking, that is CH2, not the CH. And here we are taking, that is the first one and the second one and that the third one. Now, give the difference. What is the difference between these two? The first reaction, Markovnikov rule, the Br minus is attached to second carbon. But here the Br minus is attached to, that is a first carbon one bromopropane. So that we are get, it is CH3 and bond, it is CH2, and here it is CH2 and it is Br. So Br is attached. Br is attached to the first carbon. So we are getting that. It is, sorry, here it is 2 bromo and here 1 bromo. So here it is 1 bromo, 1 bromo propane, 1 bromo propane. But here we are getting, it is 2 bromo propane. So we are get, it is 2 bromo propane, and here it is 1 bromo propane. So here it is 2 bromo propane is a major product in absence of peroxide. Absence of peroxide. But in presence of peroxide, 1 bromo propane is a product. Okay. Now, what is the mechanism of this one? And here, if you are taking Markovnikov rule, it follows carbocation mechanism. So we are get, that is a carbocation. So here it is a carbocation. So carbocation is formed. So it follows carbocation mechanism. Carbocation mechanism. So we are getting the carbocation, and in the carbocation we are getting, that is a tertiary carbocation is more stable than the top secondary carbocation and that primary carbocation. And here, if we are taking anti-Markovnikov rule, it follows, that is free radical mechanism. Free radical mechanism. So it is free radical mechanism. So what is the difference between Markovnikov and that anti-Markovnikov rules? So Markovnikov rule is nothing but the negative part of an addendum is going to attack a carbon which contains least number of hydrogen in unsymmetrical alkene. Okay, and it is also an addition reaction, and it follows carbocation mechanism, and the stability order of carbocation is tertiary, secondary, and primary. Now, if you are taking anti-Markovnikov rule, where it is applied, the alkene is unsymmetrical. It is the first one. Then second one, in presence of peroxide. In presence of peroxide. So in presence of peroxide, we are taking the anti-Markovnikov rule, then it is the mature product. Now we are taking the mechanism. It follows free radical mechanism. Okay. Now we may see the details of anti-Markovnikov reaction. Okay. Now we are taking the propene, and first we are taking the peroxide. What is the peroxide we are using in anti-Markovnikov? So generally we are using the organic peroxide, that is benzoyl peroxide. You know that benzoyl. So listen here. It is C6 H5 CO is known as benzoyl. So it is benzoyl and it is peroxide. Peroxide means bond O, and here it is a CO C6H5. So this is the benzoyl peroxide. What is that? It is benzoyl peroxide. Benzoyl peroxide. So we are using a benzoyl peroxide, and this benzoyl peroxide undergo homolytic cleavage. So that here it is homolysis. What do you mean by homolysis? And it is nothing but equal share. What will happen? Here, a bond is made up of, we are taking that, a bond, we are taking the peroxide bond, and the peroxide bond, any bond is made up of, what is it? 2 electrons. So here 1 electron and here 1 electron. It has 2 electrons. Okay. And it is equal sharing. Equal sharing. What do you mean by equal sharing? That means each one oxygen takes up an electron with equal number. So we are taking this bond is going to here and this bond is going to here. We are getting that. That is a peroxide. So peroxide cleavage will occur. So we are getting it is a C6H5 and it is a C double bond O, and that here O, and with 1 electron. 1 electron, it is 2 molecules, so that it has 2 molecules, so it is the component. Now, what will happen? Here, a bond is made up of 2 electrons here. We are taking this is 2 electrons, so that it has 2 electrons. Correct? A bond is made up of 2 electrons. Now, this will move and remove of carbon dioxide, so that the oxygen free radical is come here and with 1 electron, and this is also come here with 1 electron, so that we are getting that is a phenyl free radical. So what is the product here? We are getting that is a phenyl free radical. So what is that? Here it is a C6H5. C6H5, and it is a free radical because it has only 1 electron, so that it has only 1 electron. So phenyl free radical. Phenyl free radical. And the byproduct, it is converted into carbon dioxide. That is C double bond O, and it is a sigma bond. And here we are making free radical to bond, so it is a CO2. So we are get that is this phenyl free radical. Phenyl free radical. Phenyl free radical. So we are get there is a phenyl free radical. Okay. Now this phenyl free radical. So we are taking this phenyl free radical is reacted with the HBr. So it is the first step. Now, in a second step, we are get that is the phenyl free radical. What is it? It is a C6H5 with one electron. With one electron. Now, this phenyl free radical is reacted with the HBr. It is reacted with HBr. So, it is reacted with the H bond Br. H bond Br. And the bond is made up of two electron, here one electron and one electron, and it will be produces that is a bromine free radical. So what is that? Here we are get that is a C6H6 benzene, and that is a Br free radical. This is Br free radical. So we are getting this Br free radical by this mechanism. So what will happen here? The hydrogen is going to attach with free radical and Br free radical is formed. So here this bromine free radical is formed when benzoyl peroxide on homolysis or homolytic cleavage. And this bromide free radical, so listen, we are taking that is anti-Markovnikov rule. So what is it anti-Markovnikov rule? Here we are taking that is the bromide free radical is going to attack that is the first carbon. Now we are taking that is propylene. So we are taking a propylene. Now we are taking that is propylene molecule. So we are taking the propylene molecule. So it is a third step. We are taking that is a CH3 bond CH double bond CH2. That is propylene. And this propylene is reacted with this bromine free radical. So we are taking the bromine free radical. We are taking that is reacted with bromine free radical. So what is that? Here it is bromine free radical. Okay. Now there are two types of H, and here there is a sigma bond. Another one there is a pi bond. So which one is a weak bond? That is the pi bond is a weak one. And the pi bond is also contains two electrons. And the two electron, it is homolytic cleavages on propylene, then bromine will be attached. So it may be attached in first carbon or maybe a second carbon. Suppose it is attached in that second carbon, what will happen? So listen, we are saying that is attached with that second carbon. So we are saying that is CH3, and here it is CH, and it is attached with bromine free radical, so that it is make a bond that is a Br, and that here it is CH2. So we are taking that is CH2, CH2. Then we are get this is the free radical. So we are getting that this is CH2, CH2, and we are getting the free radical. So we are getting this type of free radical. Okay. Now one more possibility is here it is attached with that the first carbon. Then what will happen? So we are getting that is a CH3 bond. It is a CH. And here it is CH2, and here it is Br. So there are two possibilities. Br, that is bromine free radical, may be attached. It may be attached with the first carbon, or it may be attached with the second carbon. Then we are getting that is two type of free radical, and here also there is a free radical. Okay. Now listen, here there are two type of free radical. That is the first one. We are take this one. It is the first one, and here it is the second one. Okay, in a first reaction, we are getting a primary free radical. What is primary? The carbon is attached with only one carbon. That is, here we are taking the product of first reaction. What is it? This carbon, what is it? This is the carbon. It is attached with only one carbon. But here, in a second reaction, this carbon is attached with two other carbons. So that this is the primary carbon. And this is the secondary carbon. Okay. So what is the primary? A carbon is attached with only one alkyl group. Depending upon the alkyl group, we are taking. And it is easily identified. Here a carbon is attached with one carbon, then it is primary. And a carbon is attached with two carbon, then it is secondary. If the carbon is attached with three other carbon, then it is tertiary. So here there is no tertiary at all. Okay, so we are taking that it is primary free radical and the secondary free radical is formed. So it is the primary free radical. What is that? It is the primary free radical. So primary free radical is formed. Primary free radical. Now, this is the secondary free radical. Secondary free radical. So, among this primary and secondary free radical, we may take the stability of a free radical. So, listen, that is the stability order of free radical. So, stability order of free radical. What is a stability order? And it is same way as carbocation. So, what is it? Here it has tertiary is greater stable than it is a secondary and it is the primary. So, tertiary free radical is more stable than the top secondary and that is primary. Now, among these two free radical, which one is most stable? That is a secondary free radical is most stable, correct? So, which one is most stable? It is most stable, so that it is most stable free radical. Most stable free radical. It is most stable. Then it is less stable free radical. So here this is less stable free radical because this is the primary free radical. Okay. Now further it is going to attack this hydrogen, that is HBr. So it is attracted with that HBr. So we are taking that, then it is reacted with HBr. What will happen? So we are saying it is reacted with HBr. So the secondary free radical is reacted with H bond Br. HBr. Then hydrogen free radical is going to attack this secondary carbon and make a product. So the product is, what is it? Here it is CH3 bond CH2 bond CH2 bond. It is Br. Then it is 1 bromo propane. So 1 bromo propane. And here 1 bromo propane is a major product. 1 bromo propane is a major product. Why 1 bromo propane is major product? Because we are getting the most stable secondary free radical. And In the case of this reaction, what is a primary free radical? Here also it is reacted with HBr. It is reacted with HBr. So it is reacted with HBr, and the H free radical, hydrogen free radical is attached with this primary free radical and give that a product. So the product is, what is that? Here it is CH3, and here it is CH, and here it is CH3, and it is Br. We are getting that Br, and it is a minor product. It is a minor product. Why? It is 2 bromo. What is that? It is 2 bromo, 2 bromo propane. 2 bromo propane. So 2 bromo propane is a minor product. Minor product. Why? This is the minor product. Because it has less stable free radical. That is, primary free radical is less stable. So, in presence of peroxide, we are get 1 bromopropane is a major product. 1 bromopropane is a major product. Now, we are taking that here. This is applicable only for HBr. Why? If you are taking that HCl or HI, this is not applicable. Anti-Markovnikov reaction is applicable only for HBr. Why? Suppose if you are taking that is HCl, HCl, and the HCl molecule, the bond enthalpy, which is in HCl molecule, the bond enthalpy is 430 kilojoules. 430 kilojoules. So it has 430 kilojoules. So it is 430.5 kilojoules per mole. In the case of HBr, then it is 363.7. So it is HBr. So the bond enthalpy values, that is 363.7. So that it is 363.7 kilojoules per mole. Kilojoules per mole. Okay. Now, in the case of HI, it is 296.8. That is hydrogen bond ion. Then it is the value, that is 296. 296.8 kilojoules per mole. 296.8 kilojoules per mole. Now, anti-Markovnikov product is applicable only for HBr. So, anti-Markovnikov reaction, we are using only that HBr, not that HCl or HI1. And we may compare that the bond enthalpy. This is the bond enthalpy values. So, these are bond enthalpy. And the bond enthalpy value in the case of HCl, it has a very great. And if you are taking the reaction, what is that? In the reaction, you know that is a phenyl free radical, that is a C6H5 free radical. Phenyl free radical is reacted with any of this. It is reacted with, that is HBr or HCl, or that is HCl first. And these phenyl free radical cannot be cleaved this HCl molecule, so that there is no reaction at all. So because it has highest bond enthalpy value, highest bond enthalpy value. But in the case of HBr, while it is reacted with HBr, so it is reacted with HBr, then it will be produces benzene, that is C6, H6, and that Br free radical. So Br free radical is formed in the case of HBr. There is a reaction. And when the phenyl free radical is also reacted with the HI, it is also reacted with the HI. Then we are getting the C6H6. It is a C6H6, and also that is iodine free radical. Iodine free radical. But in the case of HI, what will happen? It is furthermore reacted with the HI molecule. Furthermore, it is reacted with the iodine free radical, and make that I2. So I2 is easily formed. But in the case of bromine free radical, it is not easily formed. That is bromine. Is bromine molecule is not easily formed. So it is a somewhat stable free radical. It is a stable free radical. So that this anti-Markovnikov rule is applicable only with the HBr. So only with the HBr, anti-Markovnikov rule is applicable. Anti-Markovnikov rule is applicable only with HBr. Now, if you are taken, that is 3-methyl-1-butene. We are taking, that is 3-methyl-1-butene. So listen, if you are taking that is 3-methyl-1-butene. So CH3, CH3 bond, CH, double bond, CH2. Then it is reacted with the HBr. It is reacted with HBr. What is the major product? What is the major product? Major product. Find out the major products and it is Markovnikov or anti-Markovnikov. Okay. Listen, it is the Markovnikov, correct? Because the absence of HBr, absence of peroxide. Okay. And it is the absence of peroxide. Then what is the Markovnikov rule? Here we are saying it follows Markovnikov. It is Markovnikov rule. So it follows Markovnikov rules. Okay. And here, what is the Markovnikov rule? What is it? Major. What is it? The major product is, that is the negative part of your adentum is going to attack a carbon which contains least number of hydrogen. Correct? And so that the product is, what is the product? If you are doing like this, suppose Br is going to attack that is the CH. Br is going to attack the CH, and hydrogen is going to attack that CH2. So we generally writing this way, that is CH3 bond CH, and here it is CH3 bond, it is CH Br bond, it is CH3. Now, the product is correct. This is not a major product, but according to Markovnikov rule, we made them the correct rule. But this is the wrong one. This is the wrong one. We may analyze here. And here, there is a possibility of tertiary carbocation formation. So, according to Markovnikov rule, what will happen? here we are getting that carbocation. We are getting that carbocation. That is the primary and that secondary. So here the secondary carbocation is formed. So we are take that. That is a secondary carbocation. So what is the secondary carbocation? It is a CH3, and here it is a CH, and here it is a CH3, and it is a CH, and it is carbocation, and here it is a CH3. This is the carbocation form. So this is carbocation. Carbocation. And this carbocation formation only in the case of Markovnikov flow. If it is anti-Markovnikov, then we are undergoing that is free radical mechanism. Now, this is the secondary carbocation. Now, the secondary carbocation may be converted into tertiary because there is a possibility of that. So, this secondary carbocation, what will happen? It is converted into tertiary carbocation. Now, here there is a hydride cell. What is that? It is hydride cell, that is H minus cell. So, because of stability, it is a hydride cell. So, we are getting that is a hydride cell. Okay. So, the H minus is going to here. So, we are getting a tertiary carbocation. So, what is that? That is a CH3 bond C plus, and here it is a CH3 bond, it is a CH2, and here it is a CH3. So here the further it is reacted with, that is Br minus. So it is reacted with the Br minus, and we are getting the major product. What is that? Here it is a CH3 bond C, and here Br and CH2, and here it is a CH3 bond, it is a CH3. So while we are taking that this compound, so what is that? This is a compound we are taking, that is a 3-methyl 1-butene, and 3-methyl 1-butene is reacted with the HBr, then we are get 2-bromo 3-methyl butane is not a major product. Then which one is a major product? That is 2-bromo 2-methyl butane. So this is the major product. This is a major product. So the major product they are asking. So this is not a major product. If you are doing like this, according to Markovnikov, then it is a wrong one. Why? Because here we are getting there is a possibility of tertiary carbocation. This is tertiary carbocation. So tertiary carbocation is formed, then we are getting a major product. So this is a tertiary carbocation, and here we are take secondary carbocation, so that there is a hydride ion cell. Hydride ion cell is possible. Now this is Markovnikov and that anti-Markovnikov rule. And this anti-Markovnikov rule is otherwise known as that is Tarrasch effect also in presence of metals. Now, the next one is addition of sulfuric acid to alkene. So, we are taking addition of sulfuric acid. So, the next reaction, addition of sulfuric acid. Addition of sulfuric acid, that is H2SO4. And you know that the structure of sulfuric acid. What is the structure of sulfuric acid? Listen, this is the structure of sulfuric acid. That is a S double bond O and double bond O, and here OH, and here there is OH. This is sulfuric acid, H2SO4. Okay. Now, when propylene is treated with sulfuric acid, what is the product? Listen, we are taking the propylene. So, what is it? Propylene, that is CH3 bond CH, double bond CH2. Then it is unsymmetrical alkene. Then it is reacted with sulfuric acid. What is that? H bond HSO4. And it is nothing but H2SO4. Okay. Now we are taking that is H plus and HSO4 minus. So that it is unsymmetrical alkene, then there is a cation and anion. So that we are using Marconi-Karp rule. So what is that? We are using Marconi-Karp rule. Marconi-Karp. Okay. What is it? The negative path of adenine is going to attack a carbon which contains least number of hydrogen. Which one is the least number of hydrogen? That is the second carbon. So this is the second carbon. So HSO4 minus is going to attack the second carbon. So that here the sulfuric acid structure, that is this one. What is that? HO S double bond O OH. So one of the hydrogen is going to attach with the CH2 group. This one is going to attack the CH2 group. And remaining part is attached with the CH. So we are getting the product. Listen, we are getting that is CH3. So let's that is CH3 bond, that is CH, and it is attached with the O and SO2H, and remaining hydrogen is attached with the CH2, so that we are get that is a CH3. So this is the product. So it is hydrogen sulfide. Hydrogen sulfate. So propyl hydrogen sulfate is a product. So 2-propyl hydrogen sulfate. Now this is on hydrolysis. So it is on hydrolysis. We are getting the product. What is that? CH3, and here it is a CH, and here there is a OH, and that here it is a CH3, and we are that is H2SO4. H2SO4, because H2SO4 is a catalyst and it is utilized for hydrolysis reaction. So we are 2-propanol. So we are 2-propanol is the product. 2-propanol. This is an alcohol. So alkene is used to preparation of alcohol. Okay. And the next reaction with Bayer's. What is that? Bayer's reagent. So what is that Bayer's reagent? So reaction with Bayer's reagent. Bayer's reagent. What is that Bayer's reagent? Listen. Bayer's reagent is one. It is called alkaline potassium permanganate. So we are taking that is called alkaline potassium permanganate. Potassium permanganate is known as Bayer's reagent. So cold alkaline potassium permanganate is Bayer's reagent, and it is nothing but dihydroxylation. Suppose we are taking that is ethylene molecule. So we are taking ethylene, that is a CH2, double bond CH2. One, it is reacted with potassium permanganate, that is cold alkaline potassium permanganate. So it is KMnO4. KMnO4. And it is an oxidizing agent. It is an oxidizing agent that will be produces oxygen. So in presence of water, under that oxygen, the KMnO4 is reacted. So KMnO4 is a catalyst. So actually it is reacted with the water and that oxygen, so that we are get dihydroxylation. So we are get that is a CH2OH. It is from water. And also another one CH2OH, because so many oxygen will be produced by KMnO4. And now this KMnO4 is converted into MnO2. The KMnO4 is converted into is MnO2. Okay. So here we are get that is a glycol 1,2 ethane diol, that is known as glycol. They take glycol. So it is a dihydric alcohol because it contains two OH group. Now here in the case of this reaction with the KMnO4, the manganese oxidation state will be changed. Now in KMnO4 it is a +1 oxidation state. So that in KMnO4, Mn is +7 oxidation state. And Mn is +7 oxidation state, then it is a purple in color. It is purple in color. So it is a purple. So this is a purple in color. Okay. So this purple solution, listen, this purple solution is converted into dark green. It is converted into dark green. That is Mn +6 oxidation state. Then it is in the green solution. It is converted into green solution. Okay. Now this is again converted into MnO2. In MnO2, it is Mn +4 oxidation state. Then it is a dark brown. This is dark brown. So we are taking that is Mn +4 oxidation state. Then it is dark brown. So we are getting that is a brown solution. So that here in KMnO4, listen, in KMnO4, Mn is +7 oxidation state. So that it is purple. And here it is converted into Mn 6+ oxidation state, then it is a green. And in MnO2, then Mn is +4 oxidation state, then it is become that dark brown. It is become that dark brown. So these are the color changes occurs in reaction with the various reagent. And the next reaction, it is reaction with acidified potassium permanganate. Listen here, reaction with the alkaline potassium permanganate, and the next it is reaction with the acidified potassium permanganate. So the reaction with acidified, that is H+ and potassium permanganate. So alkaline potassium permanganate may act as a phase reagent. So we are get a glycol as a major product, that is dihydroxylation. Now acidified potassium permanganate, and it is oxidizing agent. So depending upon the alkyl group attached with alkene, we are getting a different product. Suppose if you are taking that is 2-butene. Get 2-butene. Listen, we are taking 2-butene. What is it? CH3 bond CH, double bond CH bond. It is CH3. Then it is reacted with acidified potassium permanganate. Acidified potassium permanganate. Then what is the product? Then we are getting that is aldehyde. You get the aldehyde. So because acidified potassium permanganate is the best oxidizing agent, so that here we are getting that the aldehyde. So we are get two molecule of aldehyde, that is CH3 bond CHO, and the bond cleavages, that is a double bond will be cleavages. So we are getting that CH3 CHO. Further, it is on oxidation because we are using acidified potassium permanganate. So it will be converted into, that is acid, that is CH3 COOH. CH3 COOH. So we are get aldehyde and acid. Now, if you take, that is 2-methyl propene, 1-propene, 2-methyl 1-propene. Suppose we are take this one, that is CH3 and C, and here it is CH3 double bond CH2. Then it is treated with acidified potassium permanganate. What is the product? Acidified potassium permanganate. Then what is the product? Then it is on oxidation. We get ketone and the carbon dioxide and water. So we are get a ketone. So what is it? It is a CH3 and C double bond O, and here it is a CH3 and plus, that is a CO2 and that H2O. CO2 and that H2O. So we are get, that is ketone and that carbon dioxide and water. So with alkaline potassium permanganate, listen here, it is alkaline potassium permanganate. Alkaline potassium permanganate, it is a dihydroxylation. That is 2 OH group will be added. So we are get alcohol, dihydric alcohol. With acidified potassium permanganate, we are getting that aldehyde and the ketone and also that acids. And then next one, it is the most important reaction, that is ozone analysis. So we are treating with alkene with ozone, and it is known as ozone analysis. So it is ozone analysis. So the next reaction, it is ozone analysis. And here, the ozone analysis is a process that is oxidative cleavages, that is cleavaging of double bond. Then it is known as ozone analysis reaction. Suppose we are taking any alkene. Suppose we are taking this one, that is ethylene, that is CH2 double bond CH2. When it is reacted with ozone, what is that ozone? It is O3. When it is reacted with the ozone and form that ozone 9. What is that? Ozone 9. So what is that ozone 9? Listen, we are take here, it is a CH2. And ozone analysis is a process cleavaging of double bond. That is, double bond will be cleaved completely. So here there is no bond between CH2 and that CH2. And the 3 oxygen atom is attached like this. Here that is oxygen, and here there is a oxygen, and here there is a oxygen. Then which is known as ozone 9. What is that? It is ozone 9. So it is ethene ozone 9. So we are getting, it is ozone 9. It is ozone 9. And further, it is reacted with zinc and water. Zinc and that water. Then what will happen? There is a cleavages. There is a cleavage. And the cleavages occur like this. This is the cleavages. Here, there is a cleavage. And so here, it is CH2 And here the bond CH2. So the cleavages is occur like this, that is CH2O and that CH2O. So CH2O is nothing but that is HCHO. So we are get formaldehyde. That is two molecule of HCHO. So formaldehyde is a final product. Formaldehyde is a final product, and this oxygen that will be liberated as a hydrogen peroxide. Okay. Now it is a easier way. How will you find out the easier way, the major product in ozone analysis? Just very simple. Listen. Either side of your double bond, just cleave it and add it oxygen and add it oxygen here. Then it is a simple trick to identify the product of ozone analysis. So what is it? CH2O and CH2O, that will be written as HCHO. That's all. So this is a simple trick you may utilize in neat. Okay. Now we are taking that is propellant. So what is it? So it is for neat trick. So here it is propellant. So we are taking that is a CH3 bond CH double bond CH2. And using the trick, what is that? It is reacted with ozone. What is the product? It is either side of a double bond, we may claim that this double bond is claimed, and here O and that here O. Correct? So what is the product? It is acetaldehyde and that formaldehyde. And by taking the reaction, so here we may take the reaction. So we are taking this reaction. So by taking the trick, we may identify the product. Now it is ozonide formation. So what is the ozonide? Here we are get that is CH3, and here it is CH. There is a cleavages of double bond, so CH2, and here it is oxygen, and here oxygen and oxygen. This is also nice. Now it is reacted with zinc. It is reacted with zinc and water. So zinc and that water. Then we are getting acetaldehyde. What is that? That is a CH3 bond CHO acetaldehyde and that formaldehyde. HCHO formaldehyde. So acetaldehyde and formaldehyde is the product. Then this process is utilized to identify the position of a double bond. So ozone analysis is used. It is used to identify. It is to identify position of a double bond. Position of double bond. Position of a double. How this position of double bond is identified? If formaldehyde is one of the products, then the position of double bond should be the any. Listen, any alkene we are taking. We are taking any alkene. So listen, that is CH3. It is CH3. Then it is CH double bond CH2. Then if your cleavages, formaldehyde is a product, so that is position of your double bond is the end one. So formaldehyde is one of the products that we may identify. It contains terminal double bond. So there is a terminal double bond. So this is the terminal double bond. It is the terminal double bond. So terminal double bond is identified by this reaction because formaldehyde is one of the products, because it is on cleavages we are get that is acetaldehyde and that formaldehyde. Acetaldehyde and formaldehyde. So it is the use of ozone analysis process. And the next one we are taking polymerization. So what is it polymerization? So here we are saying that is polymerization. Right? Wait some time. What is the problem? Okay, the next reaction that is polymerization. So we are saying that is polymerization. What is it polymerization? And here the monomer is converted into polymer. That is n number of monomer. Suppose we are take ethylene, that is CH2 double bond CH2. And here this is a monomer. It is a monomer. And here n number of monomer is reacted to get the larger molecule by the combination of a smaller molecule. Then we are get a polymer. So we are getting a polymer like this. That is a CH2 bond. It is a CH2 bond like this. And here there is a bond. So it is in n number. Then it is known as ethylene on polymerization. It is polyethylene. So polyethylene, which is known as the polyethylene. You know that it is a polyethylene. Likewise, we may take propylene on polymerization. So we are taking propylene. So propylene on polymerization. So we are taking propylene. What is it? Here it is CH3, and here it is CH double bond CH2. Then it is also on polymerization. We may get that is a polypropylene. So we are get polypropylene. It is a CH, and here it is a CH3, and it is the bond. It is n number, and here it is a CH2, and that is n number. So it is polypropylene. Polypropylene. So it is a polypropylene. Likewise, we may take this as styrene. So we are taking this as styrene. So what is the styrene? It is a CH2. We are taking that is a CH2 double bond. It is a CH, and it is a C6 at 5, which is known as it is a styrene. So styrene on polymerization, we are get that is a polystyrene. So we are get that is a polystyrene. That is a CH2 bond. Here it is C6 CH and C6 H5, and this is the n number molecule that we are get. It is a polystyrene. Polystyrene. So on polymerization, we are get that is a polystyrene. So we are taking so many compounds from that is alkene. And do you know that in plastic bottle there is a symbol? You know that there is a symbol like this. We are take this one. In a plastic bottle, we are taking the symbol. Listen. Are you noted the symbol? There is 1 to 7. And here there may be 1 or 2 or 3. So here there is 1 in the bottom of the plastic bottle or maybe in the side of the plastic bottle. So it represents what? Then it represents what is the use of plastic bottle and how the recycling is occurred. If the number is lowest, it is easy to recycle. If the number is highest, that is up to 7, it is not easily recycled. And also, it represents what is the type of a font. If it is 1, if it is 1, then it is PET, that is polyethylene terephthalate, that is known as PET bottle. So, if it is 1, then it is PET. If it is 1, it is PET. And if it is 2, then it is HDPE. So, 1 part, it is PET, polyethylene terephthalate. And it is 2, then it is HDPE. HDPE, high density polyethylene. High density polyethylene. And if it is 3, then it is PVC, polyvinyl chloride. If it is 4, then it is LDPE, that is low density polyethylene. If it is 5, then it is polypropylene, that is known as PP. And if it is 6, then it is polystyrene, that is PS. And if it is 7, then it is multi-layer plastic. So that it is a multi-layer plastic. Multi-layer plastic. So the plastic is any plastic bottle which contains the symbol. Listen here, there is a symbol that it is 1, 2, 3. Ever you noted or otherwise noted here. So it is PET, HDPE, and PVC, and LDPE, and PP, and the PS, and the multi-layer plastic. Multi-layer plastic. So it is multi-layer plastic. Multi-layer plastic. Okay. Listen, if you are taking the uses of these multi-layer plastics, so listen, we are taking the uses. Okay, these are the uses of multi-layer plastics. So all this, suppose if it is 1, if it is a 1, what is the use? And if it is 1, that is PET bottle, that is PET, it is polyethylene terephthalate. Polyethylene terephthalate. So it is polyethylene terephthalate and it is used for soft drink bottle and water bottle and fruit juice container and cooking oil. Okay. Then if it is 2, then it is high density polyethylene. Then it is milk jets and cleaning agents, laundry detergents, and bleaching agents, and shampoo bottle and washing bottle. So the shampoo bottle, it should be, what is that? The shampoo bottle we are taken, then it is the shampoo bottle, it has 2. The we are taking the shampoo bottle, it is 2. It is the 2. And we are taking if it is 3, then it is polyvinyl chloride and it is used for, that is the trays and the street boxes, and that plastic packing, and that is any foils and wrappers. And if it is 4, then it is LDPE, that is low density polyethylene. So the low density polyethylene, we are taking the low density polyethylene, that is It is a crushed bottle and shopping bags and the high resistance sacks and most of the wrappings we are using that LDP. Okay, and we are taking that number five that will be placed for that is polypropylene, which is used for the furnitures and the consumers and the luggage bags and the toys and the bumpers and the lining external borders of the cars. And if it is six, then it is polystyrene. And most of the toys it contains that is a six. And here that is cosmetic bags and jewelry bags also that is polystyrene. And seven, then it is other plastics including acrylic and polycarbonate and the polyactive fibers and the nylon fibers. Okay, and we are taking these are the uses. So alkene is used in many industrial applications. That is, they are used starting material for the synthesis of alcohols and the plastics and the liquids. And also, we are taking the uses. Ethene is the most important organic first organic feedstock in the polymer industry, and it is a PVC and also polyethylene and the saran. So most of the alkene which is used for that polymers, and these are the uses of polymers. Okay, go through your book, student, and read well. We may finish alkene.